D has what type of denominators? Monomial or binomial? You didn't know what that is. Oh, look at this. Front row special. So easy to see from. Just leave you that option. All right. Like curling. You're welcome. Curling clean that. All right. D has what type of denominators? Starts with M. Monomial. I thought I was going to say rhymes with phonomial, so thank you. They're monomial denominators. Monomial denominators you can make be each other, right? Monomial denominators can be monomial denominators. Totally fine. So this one has an A squared, this one has an A, so I know the right-hand side needs an A. And then what's common between 2 and 5? 10. So the right-hand or left-hand side is 2A squared. I needed, what's my common denominator between the two of these? 10? 10A squared. So this one I'm going to have to multiply by 5. Minus 3 over 5A. This one I'm going to have to multiply by 2A. So we're going to get a common denominator. We're going to get a common denominator of 10A squared. On the top, we distribute. So we get our common denominators, but we only distribute our numerators. The denominator we can put together, cool, great. We distribute our numerators. So we're going to get 5A plus 35 minus 10A squared in this denominator, 6A. So we get those common denominators so that we can rewrite them, correct? Even if we had two binomials, we wouldn't expand them because there'd be no point. Once you get a common denominator, yay, your denominators are all solved, great, perfect, just rewrite them. Boom, 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 boom. Boiling them back together, distributing them, it's just extra work for no apparent reason. All right. Now we have a common denominator, so we write them all over 10A squared. And then I get 5A plus 35, and then I have a monomial behind it, so minus 6A. And so I get 5A minus 6A is negative A plus 35, which is a what? Binomial. So it can go in its own brackets. Does it have to go in brackets? No. I'm putting it in brackets because you guys illegally cancel like no one's business. And by you guys, I mean all the students in Alberta. From now since 2012, I'm probably right. All right. When the curriculum changed. All right. Can I cancel anything off, guys? I have a binomial in the numerator. I have a monomial in the denominator. Can a binomial ever cancel a monomial? No. No. They're stuck. Okay. I still have state non-permissible values.
How'd you get negative A on the top?
You have 5 apples and you take off 6 apples. You have a deficit of an apple. Yeah. 10A squared. What's my non-permissible value? Yeah, just 0. 10 doesn't get me anything. And A squared is A times A. So it's just A 10 equals 0. On the test, they won't have bracketed the numerator. If it's multiple choice, don't panic. Okay, then we're going to flip over and deal with some binomials too. All right. E, left-hand side is a what? Left-hand side is a monomial. Right-hand denominator? Yeah, binomial. We're talking about denominators because our first goal is to get common denominators, right? So left-hand side denominator is a monomial. Right-hand side is a binomial. You should throw a party when that happens. You want to know why? Can't make a monomial be a binomial. You can't make a binomial be a monomial. So you just multiply by each other. It's the easiest question out of all the questions. One's a monomial, one's a binomial. You multiply by each other. You can't make them be each other other than multiplying them. So what does that mean? The left-hand side, I have x minus 9 over 2x. What am I going to multiply by? x minus 4. No thought process. I literally just multiply by the binomial. Why did you now just randomly switch to black again? So many questions. So little. Oh, and the blue box. Great. Awesome. Cool. Plus, yeah, 9. On this side, we have 3x, x minus 4. And what am I going to multiply this side by? I believe it's going to be gone. The monomial 2x, yeah. Why? On both my computers, is the blue box a thing today? Stay there. All right. Do I have common denominators now? 2x, x minus 4, x minus 4, 2x. Do I have common denominators now?
Yes.
Yeah. So should I put them together because that would be fun? Or just say, hey, I got common denominators, yay.
Just say it.
Hey, I got common denominators, yay. If you put them together, your NBD is going to be really hard to find, correct? So would that be helpful putting them together? No. So this denominator is 2x, x minus 4. Yay, I have a common denominator. This one is 2x, x minus 4. Yay, I have a common denominator. You agree? What do I have to do with the numerators? Starts with a D. Rhymes with distribute. Distribute. Geniuses. Okay. So this one is being, if I leave it like this, that just means the 9 is being distributed in. Is that what I want to do? No. So I have to make sure that I put this in brackets so that I mean that I'm going to distribute everything together. Right? Because that's why binomials go in brackets. So we do first times first. So x times x, x squared. Then we do x times negative 4 outside, negative 4x. Then we do inside, negative 9 times x, negative 9x. Negative 9 times 4, positive 36. Then the back, we go 3x times 2x is 6x squared. Now it's no different than what it was before. When we get a common denominator, what can we do? Write it all over that denominator. We agree? Yeah? So, we are going to get 2x, x minus 4. And in the numerator, we're going to get x squared minus 4x. You could put these together right now, but I'm going to wait. Minus 9x plus 36 plus u plus 6x squared. Do we agree? I've done nothing crazy, right? I distributed, and then I rewrote the whole numerator, yeah? Yeah, that's the next step. So now we're going to get all over 2x, x minus 4. Now the numerator, we have to put together what's the same thing. So I like calling x's xylophones. I like calling x squareds x-rays. You're welcome. 1 x-ray plus 6 x-rays is 7 x-rays. Can I add an x-ray to a xylophone? No, that's stupid. So when you guys are doing x squareds and x and putting them together, you're like adding x-rays to xylophones. You would end up with x-rays and xylophones. They can't go together, right? Okay, minus 4 xylophones. Minus 9 xylophones is how many xylophones? Negative 13 xylophones. And then 36 nothings is just out here. Is there anything I can take out of that numerator? I'm going to rewrite it up here because it's awfully squishy. 7x squared minus 13x plus 36. Is there anything I can take out of that numerator? Nope. And I can't factor it, so it's dead. It just sits there. 2x, x minus 4. What do I have to make sure I still do, though, guys? Yeah, x can equal what? 4 and 0. So when you get a monomial and a binomial, life is easy. You just multiply by each other, correct? A lot of people get stuck. They're like, I don't know what to do. That's the easiest one. Don't use any brain matter. Just multiply them by each other. Okay? Let's look at f. Let's discuss it. Our denominators, what are they both? Binomials. Can you make a binomial be a binomial? Sometimes, yeah. Like if you had, side note, just everyone's paying attention. If you had a denominator that was 2x plus 8, plus, and you had a denominator of x plus 4, could I make these binomials be the same? Right, so I could take that 2 out of here, and then I would have x plus 4, and then I would have to just multiply this by 2. We agree? So sometimes you can make the binomials the same. But if you can't GCF or difference of squares anything to your binomials, you can't make them the same. Therefore, you have to multiply them by each other. Like this one, you could make them be the same. But this one, I have 2y plus 5. Can I take anything out of that or change it? Can I? I can't. And then I have y minus 3. Can I take anything out of it or change it? No. So if I can't do anything to those, how do I make a common denominator? Multiply them by each other. That's it. That's all. Monomial are the harder ones because you can actually make them be each other, correct? But these two, you can't. So I'm going to rewrite it as 4 over 2y plus 5. And what am I going to multiply this one by? Y minus 3. Would distributing the denominators make my life better? Think about it. Because a lot of you guys just do stuff because you see brackets and you just go wild. Would distributing the denominators make my life better? Or would it make it harder to find restrictions? It would make it harder to find restrictions, right? And will I have common denominators when I have those two brackets side by side? Yeah? So would distributing them make it better? No. So I'm going to just rewrite that, and then minus 1 over y minus 3. And then I multiply by 2y plus 5. So can you tell me what would possibly be the next step? Can't collect by terms yet. That's the next one after this. Yeah. You have to distribute. So the brackets in the numerator go away. Because if you have brackets in your numerator, you can't collect like terms. Yeah? Yeah. Do we distribute our denominators? No, we already have common denominators. Distributing them wouldn't make our life better. So we're going to go 4y minus 12 all over 2y plus 5, y minus 3, minus, distribute that in, I get 2y plus 5 all over 2y plus 5, y minus 3. Okay, what's always good is if you can spot where the common errors would be. If you can spot where a common error would be, you won't make the common error, correct? So where's the common error going to happen on subtraction, the binomial behind it? Yeah. You'll apply that negative to the 2y, you'll subtract the 2y, but you'll forget to subtract the what? The 5. And will the answer be there if you do that? Yeah. It's the biggest error that happens out of everything. Okay, so let's spread it out. So we have a common denominator, so we're going to write it over that. 2y plus 5, y minus 3. And then our numerator is 4y minus 12. The last one didn't matter because we had a plus sign in between, but when we have a subtraction sign, we have to subtract everything behind it. So we're going to subtract the 2y, and we're also going to have to remember to subtract the 5. And if you're someone who's like, man, I forget to do that all the time, I would highlight it. Remind myself, a little reminder that I need to remember to distribute that minus sign. And why do I say that? Because so many people don't remember to do that. And now I can do what? Like terms. 4 yaks minus 2 yaks is 2 yaks. Negative 12 nothing minus 5 nothings is negative 17 nothings. All over 2y plus 5, y minus 3. Y can't equal what, guys? Do you remember? we don't, we go up here. 2y plus 5, this is why we don't distribute them together. 2y plus 5 can equal 0. I subtract my 5. 2y can equal negative 5. Divide by 2. And y can't equal negative 5 over 2. And then I have y minus 3 can't equal 0. Add 3. Y can't equal 3. And I have to follow behind that. Comma. Y can't equal negative 5 over 2. And 3. Let's look at G. G has x minus 5, which is a what? Binomial. And x plus 1, which is a what? Can I make them be the same? Can I GCF anything out of them to make them be the same? So if I can't make them be the same, what do I have to multiply by? Each other. Try it out. So we have x minus 5, x plus 1. We have an equal sign. Check and make sure you are actually using equal signs. These are all simplifying expressions. So this one. So guess what, guys? If you plugged a number in for x in every single step, any number, like a 2 or a 3 or whatever, every step would come out to the same answer because they're equal. You could check your steps by just verifying, right? Okay. So we get 2x plus 1 over x minus 5, and we're going to multiply that by x plus 1. And then this is a binomial, so it needs brackets. Minus x minus 4 over x plus 1, and we get x minus 5. So we distribute, and we get 2x squared plus 2x plus 1x plus 1 all over x minus 5x plus 1 minus x squared minus 5x minus 4x plus 20 x minus 5x plus 1. Okay, a lot of people try and skip the next step. If you skip the next step, you are liable to 1, using less pencil, cool. 2, making a mistake. I would use more pencil and not make a mistake and do the next step. So we have a full denominator, x minus 5x plus 1. And in the top we get 2x squared plus 2x plus 1x. If you can put that together as a 3 at this point, go ahead. But now we have to subtract every term behind it, which just changes the sign of it, correct? So we're going to get minus x squared plus 5x plus 4x minus 20. And so I get 2 x-rays minus an x-ray. I'm left with 1 x-ray. I can write the 1 or not, doesn't matter. 2 xylophones. And 1 xylophone is 3 xylophones. And 5 xylophones is 8 xylophones. And 4 more xylophones is 12 xylophones. 1 nothing minus 20 nothings is negative 19. Can I take anything out of this numerator? No. Can I factor it? Multiplication, what multiplies can be 19, 1 and 19. Ooh, 1 and 19 doesn't give me 12. So that's done. X minus 5, x plus 1. If it says to determine the non-permissible values, and you just write them, have you determined them? No, so we need to make sure we read. If it just says state the non-permissible values, state away. So stating them would be like x can't equal 5 and negative 1. That's a statement, correct? And then you would say non-permissible values are if it asks that. If it asks you to determine, though, you have to set each of these not equal to 0 and find them. Okay, H. What's the catch with H? There's a square in the denominator, and I told you guys this, and I want to repeat it again. most often than not when people are stuck, if you're getting a cubed, be sus. We don't get cubes as much in this, so be a little sus. It might be true, but 99.9% of the time you just missed something. Which in this case you might have missed that the bottom left-hand side, so the denominator on the left is a difference of squares. And you often miss difference of squares, everyone listening? When one of the numbers is 1. When one of the numbers in the difference of squares is 1, you don't spot it's a difference of squares. 4 screams perfect square, 9 screams perfect square, 16, 25, 36, they all scream it. 1 doesn't scream it. And why do I know that? Because that's often where people are stuck at, every single time. So, p squared minus 1 is a difference of squares, so we're going to deal with that first. We're going to get 4 over p plus 1, p minus 1. Plus 2 over p plus 1. So we have 2 binomials on the left, 1 binomial on the right. Do we have any binomials in common?
Yes, but not both.
Yes, but not both. So in common, we have a p plus 1 on both sides. How can I make a common denominator?
Add a p minus 1 to the right side.
Yeah. So we have to multiply this one by p minus 1. I do the denominator, I do the numerator, I change the whole expression. So I'm going to get 4 over p plus 1, p minus 1, plus 2p minus 2, p plus 1, p minus 1. There's no point in distributing them. If you do, you're going to have to factor them back to get your non-commensal values. We have a common denominator, so we write it all over that denominator, p plus 1, p minus 1. And then I get 4 plus 2p minus 2. Then what do? Starts with a C. Rhymes with elect-like terms. Oh, yes.
I don't think that's mine.
2 pumpkins. There's no more pumpkins. And then 4 nothings minus 2 nothings is plus 2. Is there anything I can still do to that numerator?
Yeah, you can take 2.
You can take a 2 out. Oh my goodness, things match. I can simplify, so I'm just going to go ahead and do that right away. Not right now. What do I have to do first? Restrictions. So you get excited that something's canceling. I see that. But you have to make sure that you do your restrictions first. P plus 1 can't equal 0. P can't equal negative 1. P minus 1 can't equal 0. P can't equal 1. Then they can cancel. And I'm left with 2 over P minus 1. I'm going to hint to IJ, I want you to try them. You can take a what out of the left denominator? A 5. And then on the right denominator, a 2. And then your binomials are actually the same. This one, the right denominator I can take out a x, and then your monomials are the same. Okay, so GCF first for I and J. Try them out. So the first one, I'm going to rewrite the 4. In the denominator, I take out a 5. And I'm left with x plus 1. In the right denominator, I'm going to take out a 2, and I'm left with x plus 1. Now, the binomials are the same, correct? It's the monomials that are not. So I need to multiply this one by 2, and this one by 5 to make the monomials the same. The binomials are good. So on the top, I'm going to get 8. And then I'm going to get 5 times 2, which is 10, same binomial. Plus 3 times 5, which is 15. And then I'm going to get 10, same binomial. So you see how the binomials are the same? And we're just making the monomials the same? And then we can just go 8 plus 15 is 23 over 10 x plus 1. And then I say x can't equal -1. To be honest, the ones where you have to take something out at the very first step, the questions are easier. You just have to spot that. So this one, I have to spot that I can take an x out. When I take an x out, I'm left with x plus 2. So look, my monomials are the same. So that's good. I just need to multiply the left by what? X plus 2, the binomial that isn't the same. So I have x plus 2. And then I get x plus 2 in the numerator. Minus 1 over x plus 2. And so I get x plus 2 minus 1 over x plus 2. And then I collect by terms. X, 2 nothings minus 1 nothing is plus 1. Top is a binomial, so it has to stay. Nothing matches. X can't equal 0 or -2. Your homework is in the workbook, page 450, number 1 to 3. I'll take pictures of it as well.